Today we're going to talk about simple probability, experimental probability, and comparing probability in our video today. First, let's talk about simple probability. In these examples, I'll be using uppercase P to stand for probability. So in our simple probability, to find simple probability, you take the probability of an event, whatever it is. If you're rolling dice, the probability I roll a 2, so the event would be rolling a 2. So the probability of an event equals the number of favorable outcomes, what you want to occur, divided by the total number of outcomes. So you can express your answer as a fraction, you can express your answer as a decimal, you can express your answer as a percent. So you have to read the problem to see how they want it to make best sense. Okay, so let's go over an example. In our first example, you randomly draw a marble from a bag, marbles containing 8 blue marbles, 5 green marbles, and 8 red marbles. What is the probability that you draw a blue or red marble? So that's our favorable outcome. So first we're going to figure out the favorable outcome. That's going to be blue and red. So we have 8 blue and we have 8 red. That is going to be 16 total marbles. So we have 16 favorable outcomes. The total number, we're going to add them all up. So we'll add the 5 green ones. And there's 21 total outcomes. The question is asking for you to write it as a decimal to 2 places. So I do 16 divided by 21. And when I do that, I get a decimal that goes pretty long on my calculator, so my answer would be 0.76. That would be 2 decimals. Okay, so that's my probability of drawing a blue or red marble. Okay, go on to example 2. In example 2, we're going to talk about experimental probability. With experimental probability, experimental means you're actually doing it. So you're taking the probability of something that's occurring, not just what could happen. So in this, we're going to take the probability event is the number of favorable outcomes over the total number of trials. So how many times we want it to occur occurred over however many times we tried something. Okay, so in our experimental probability, if we go scroll down to my example, March Madness movies served 23 lemonades out of 111 fountain drinks last weekend. Okay, based on that data, what would be a reasonable estimate of the probability the next fountain drink ordered is lemonade? Now you can look at their answers and you can see they're looking for a fraction. So I'm just going to take the number of favorable, so we're looking to see what that lemonade's next. So we take 23 lemonades divided by how many total fountain drinks there were, total being a key word there, out of 111. So that's going to be my answer, D. Now this question asked for it as a fraction, but if it did ask it for as a decimal or as a percent, you would just divide 23 by 111, and that would give you 0.207 repeating. So that would be 0.2 or 0.21 if it wanted you as a decimal. And as a percent, I would just multiply by 100 to my decimal. So that would be about 21% would be my percent. Okay, in this case they asked for fractions, so that's all you had to do there. Okay, in my last example, we're going to be comparing probability. So in this case, we're going to give you probability in a couple different forms you need to compare. Both Felipe and Enzo forgot to study for their science test. The probability of Felipe passing the test is 0.19 and Enzo is 1/4. Which is more likely? Okay, so if you look at the answers, you're going to see who's going to be more likely to pass the test. We got to compare the two numbers, so I have to compare 0.19 to 1/4. I'm going to turn 1/4 into a decimal, so 0.19 compared to 0.25. So now I know that 0.19 is less. So who's more likely to pass? Well, 0.25 is a higher number. So Enzo is the 1/4 of the 0.25, so he is more likely. So you're just going to compare your probabilities. Okay, that's all we have for today. Go ahead and watch anything else you need to. Otherwise, have a great day.